A microscopic glass cage replaced the magnetic disks in 2 billion computers. Then it locked your data inside a quantum vault. The drive contains no moving parts. The device makes absolutely no sound. Yet it traps billions of electrons to remember everything you have ever saved. You call it a solid-state drive. It sits inside your phone, your laptop, and the servers running the internet. Before 1989, computers used hard drives with physical mechanical arms. They skipped. They crashed. Those mechanical arms failed constantly. A hard drive reads data by hovering a magnetic head 3 nanometers above a spinning platter. If a speck of dust hits the platter, the drive shatters. An engineer named Fujio Masuoka at Toshiba hated this fragile design. In 1980, he sketched a completely different way to trap information. He did not use magnets. He used pure electricity and a quantum physics trick. A modern SSD is a grid of billions of tiny cells. Each cell contains a floating gate. Think of the floating gate as an empty swimming pool. Above the pool is a control gate, which acts like a diving board. Separating them is a barrier made of silicon dioxide. This barrier acts as a solid wall of glass. Electrons cannot pass through glass under normal conditions. But your computer needs to put electrons into that pool to save a file. So it applies a massive 20-volt electrical charge to the diving board. This triggers a phenomenon called quantum tunneling. The electrons do not break the glass. These particles literally teleport through the solid barrier. They appear inside the swimming pool instantly. Once the charge turns off, the teleportation stops. The electrons remain trapped inside the floating gate. These particles cannot escape. They will sit there for 10 years without any power source. That trapped cluster of electrons represents a 1 in binary code. An empty pool represents a 0. Your computer reads your files by checking which pools have electrons inside them. It does this at the speed of light. A modern drive contains trillions of these microscopic pools. Manufacturers stack them vertically to save space. A drive the size of a stick of gum can hold 2 terabytes of data. That equals 2 trillion microscopic pools of trapped electricity. And your computer checks every single one of them in milliseconds. But this quantum teleportation comes with a hidden cost. Every time an electron tunnels through the glass barrier, it causes microscopic damage. The silicon dioxide wall slowly degrades. The process resembles firing a bullet through a self-healing target. Eventually, the target stops healing. The glass barrier develops tiny cracks. Electrons start to leak out of the floating gate. When enough electrons leak, the computer can no longer read the cell. A 1 becomes a 0. Your data becomes corrupted. Every solid-state drive carries a strict death date programmed into its chemistry. Most consumer drives survive about 600 terabytes of total writing. That means you can overwrite the entire drive a few hundred times. After that, the glass barriers shatter at the atomic level. The drive permanently locks itself to protect your remaining files. You are carrying a decaying quantum vault in your pocket right now. Every time you download a movie, you degrade the glass. Deleting a photo blasts those electrons back out of the pool. You are slowly eroding the microscopic architecture inside your phone. But the math works entirely in your favor. You would have to write 100 gigabytes of data every day for 10 years to break it. By the time the glass finally shatters, you will have bought a new phone. The engineers designed it to outlive your desire to keep it. They built a flawless prison that destroys itself. And they hid it perfectly behind a touchscreen. Fujio Masuoka never got rich from his invention. Toshiba gave him a bonus of a few $100s. Today, his quantum trap runs the entire digital economy. If you want to know how the rest of your world actually works, subscribe to Aura Clips.